We're going to talk about observability and software ownership, and I have all these cool graphics that are like plastered over half the slides. I want to talk about systems because honestly, most of you here, I assume, more or less identify as software engineers. Who doesn't? Anyone here? What do you think of yourselves as? Whoa, that's heavy. Opsy people? Any Opsy people besides me and Liz? Cool, yes, there's 3 of us. 3 can take over the world. This is a talk about systems, not software, because honestly, your job is not writing software. Once upon a time, it kind of was. You kind of had an ivory tower that felt really cool because you could just like, woo, other people will take care of all the consequences. You know you don't get that anymore, and you don't want that, or you wouldn't be doing serverless stuff, right? Your job is not writing software, it's solving problems with systems. And every system has a purpose, and I've had really good luck getting people to quit their jobs lately. So don't quit your job if you don't hate it. But like a lot of people out there who are just like, I don't really believe in what I'm doing, or if you don't believe in the system that you spend a third of your life creating, find another system to work on. If you can't morally embrace it, there are many other people out there who would love you to work on their systems. So just a plug for quitting your job. Software is not only not your job, it's kind of the enemy. The best code is always no code at all. This is like 3 rules to like, you're a senior engineer if you're like, yep. The best code is no code at all. The least amount of code that you can possibly do, for the most part, is best because code is liability, right? It's literally something that you are responsible for. Good or bad or ugly. And like the second best code is code that somebody else is owning and writing and debugging, and you get to read it, right? And the third best is like literally anything else. Software is a very powerful tool, but it's not the goal. And this is something that I love software engineers. Some of my best friends are software engineers. Sorry, I like that joke. But they tend to like software too much, and they create too much of it. And that is just, it's not good for anyone. Now, we are getting better as an industry at building these large projects, building these large systems, maintaining these large systems. Do you want me to hold that?
Can you talk into this instead?
Yeah, totally. Better?
Yeah.
Cool. We're definitely getting better at this, building large project systems and teams. And I know that like on a daily basis, it often feels like everything's on fire, because it is. But if you think back to where we were 10 years ago, where the idea of having managers was still hotly controversial, or the largest systems in the world were like, ooh, maybe distributed systems are a thing. We're getting better, but not fast enough. We're not even keeping pace with the rate of change. We are super outpaced by demand and complexity, like all of these compound effects. It's Moore's law all the way down, and users are hungry, and more of the world is coming online, which is cool. But we have to do better. Way too many of our systems are basically, this is why we do so many rewrites. I created Honeycomb because when I was at Parse, in 2015, around the time we got acquired, I was coming to terms with the fact that we had built a platform that was basically undebuggable by some of the best engineers in the world, doing all of the quote-unquote right things, right? That's a very sobering wall to run into when you've got 1 million users depending on you, and suddenly you're like, whoa, we don't know what's happening. And so many of our systems are effectively black boxes to us, and that's just costly. It's costly to us in terms of money, in terms of time, and most of all in terms of like our humanity. Like none of us evolved in the savannas of Africa to be up like pounding away at a terminal like night after night. It's not good for us. I'm going to show you one of my favorite things to look at when I want to feel sad, which is the Stripe Developer Survey. Bad code. If you haven't read this, gotta go read this. Bad code costs companies easily $85 billion a year. The developer work week. Bad code, which is not the same as technical debt, mind you. About 10% of our productivity, and this is all self-reported, by the way. You may think it's a little high. I think it's a little low because I think people are kind of bad at identifying what bad actually looks like. Lots of people have never seen anything but bad. So if we're talking about systems, here's one of the elegant slides. What is a system? Well, it's the shit you write that talks to the shit other people write, and the connective tissue between them, the physical resources that they sit upon, the users who interact with it, and the humans who care for it. Like, none of these can be left out. Like, it makes no sense to talk about the microservices and like all these transformations without talking about the changes that have to happen to our teams, and the way we manage people, and the way we write our like career ladders. Like, it's people all the way down. Unfortunately, I'm sorry, but we do have to factor them in. So I'm going to touch on that briefly. I also wanted to link to one of my favorite talks ever by Lyndon B. He wrote this talk. He is a grumpy old ops engineer. I love him. It's called Attempting to Understand Our Systems. And he points out that so much of what engineering leadership is nowadays is trying to explain our systems to the rest of the world. And you can see this because the rest of the world is starting to catch up, and they're pissed. This is why all this legal regulation is coming out, and GDPR and stuff, and they're just like, you guys have no fucking idea what you're doing to your own systems, do you? And no, we don't. So we kind of have to start with ourselves, because it is, sadly, way easier to build a complex system than to try to understand it. Again, so many rewrites. Sadly for us and our little human brains, this is what's happening to complexity. Also, this is how you can tell that I was a music major and a dropout, because I just, it's true because I have a graph, but it has no data. Let's just call it true. Complexity is increasing. All right, cool. I do actually have some architecture diagrams. So there's the humble lamp stack, right, on our left. And first of all, let's just establish, if you can solve your problems with a lamp stack, please do. Please do. No question. This was parsed in 2015, kind of before microservices was really becoming a thing. We didn't think of ourselves as microservices. Like, that middle blob is a few hundred MongoDB replica instances, and one of those blobs is like, we just let developers write. It was like serverless before it was serverless, right? Write JavaScript and upload it, and I will just make it work for you. Write your own queries, upload them, and I'll just make it work. Never do this. This is a terrible idea. Developers loved it. Anyway, debugging that was basically taking up 150% of our total developer cycles, right? Because a user would write in and be like, parse is down. I'd be like, parse is not down. Like, behold my wall of dashboards. They're all green. Because, mobile traffic isn't huge. Maybe they're Disney doing 4 requests per second, and I'm doing 100,000 requests per second. Never going to show up. So I'd have to go and track it down, or dispatch an engineer to go track it down. And it could take hours, if not days, just because the sheer range of possible things could be broken. It'd be something, a query or JavaScript that they wrote and uploaded, or something that we did, or some intersection of the two, or something that a neighbor of theirs was doing that starved them of resources. Challenging. But it gets worse. This is the National Electrical Grid. And this is really what you should have in your brain when you're thinking about the systems that we are designing and managing, right? It would be folly to try and spin up a staging copy of the National Electrical Grid. It would be folly to rely on your tests and believe that they're going to tell you the truth about reality. It would be stupid to think that you can predict all the questions that are going to happen and that you have any sense of control whatsoever about what's going on there, right? Some of these problems are going to be hyper-local. A tree falls over in the middle of Main Street in some bumfuck Iowa town, right? No offense to Iowa, I come from the Midwest. But you couldn't have predicted that. You would be stupid to spend much energy trying to predict that. All you can do is gather the right granularity of information and detail so that you can detect it quickly and remediate it when it happens. Some problems are hyperlocal. Some of them are the opposite of that. Some of them you have to zoom way out to see. Like if all the bolts that were manufactured in 2003 are rusting 10 times as fast as all the other bolts, or all the bolts from a particular manufacturer or a supply chain, the possibilities are literally endless. So, welcome to distributed systems. You're a distributed systems engineer now, I'm pretty sure. I think that means you get a raise. Basically, what this means is that all of our patterns around how we design, ship, and maintain systems are undergoing what I like to think of as a pretty magnificent refresh, because we used to be under this illusion that we had control and that nothing was broken. That illusion has been shattered. We are not in control. Our systems are full of emergent behaviors that we have no idea where they came from. And they're broken all the time. Right now, I guarantee you, if you have a production, there are many things that are completely broken and you just don't know about them yet. So sleep tight. What this means is that the next version of the future, instead of dev, ops, blah, 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 a lot of this comes down to, as Liz likes to call it, production excellence, which can only really be achieved through software ownership. And honestly, this is why I'm talking about this here at this conference, because I feel like, all right, I threw a bunch of shit at serverless. Sorry, I'm cursing, aren't I? I threw a bunch of mud at the serverless community early because I'm like, the server's all the way down. I mean, I hate this term a lot. I still do, and it still is. Nevertheless, I found myself often telling engineers, when I'm talking about how to instrument things, how to do a bunch of software engineering practices, I tell them, just imagine you're working serverless code, and you'll do all the right things, right? And I caught myself saying that half a dozen times, and I went, oh shit, I'm not allowed to hate on serverless anymore, am I? So I'll point out a couple of those things along the way. But first, I want to talk about, I see ops as being, it's the how of how you deliver software, right? Dev is the what, ops is the how, biz is the why. It is not, it really drives me nuts when people try to define ops as all of the grunt work that should be automated out of existence. Because what it actually is, it's more like architecture, if architecture wasn't also a completely diluted and weird word. But it's managing your systems, right? And software is just, writing code is just a thing that you plug into systems. It's not the whole of it. It's not even the most important part of it. One of the most important things that good ops people do is they keep the amount of new code down to a minimum. I see some vigorous nods, and I love that. And honestly, I'll be kind of hardcore about on-call. I've been softened a bit on that. But if you don't want to participate in production excellence, then there are many jobs out there that do not require you to work on 24/7 available systems. But that's how I feel about it, because I think that there's this really powerful feedback loop that got severed at one point. In the beginning, God created the heavens and the earth. People wrote code on production servers and hit save, and the users saw it immediately, and they complained, right? And it was crappy, but it was a feedback loop. You got to hear when you broke something, right? And then our systems got too complex for that. And so we started spinning off all these separate roles, and we got, and somehow we ended up with one set of people writing code and the other set of people making it work. To no one's surprise, this is horrible. Because the people who have changes in their head that they've just done are the people who should be debugging it, right? So that you find it in a matter of seconds or minutes, not somebody who's like, what the hell did someone just do? Well, I'll spend a few hours or day. Ops people aren't stupid. They just don't have the context in their head, right? Ops people want to write code too. So I feel like the solution to this is to kickstart that very virtuous feedback cycle again. And that starts with, for most people, putting software engineers on call. Because you need to be exposed. Pain is nature's gift. It's how it teaches you what is right and what is wrong. If you are like, ooh, I feel a little bit oochie about this thing that I'm shipping, but I'm just going to ship it anyway and walk out the door, you're not going to develop those layers of scar tissue and intuition over time that tell you what an idiot you're being. It's necessary. But the corollary is management, leadership, senior engineers, we all have a huge responsibility to everyone that we're putting on call to not make it suck. It does not have to suck. I'm not saying, like, I know ops has had a terrible run of just self-martyrdom and abuse, right? I'm over 30 now. I don't want to be woken up in the middle of the night either. But I'm not saying everyone should abuse themselves like ops has. I'm saying it can be so much better if we don't let the systems get to that state, right? Because what you've got now is like years upon years of just accreting failure after failure and like not understanding things and pushing it under the rug. And it's just gross. It's just disgusting. And it takes a while to work your way out of that if you've gotten into that state. But like our on-call rotation, we consider it a thing to postmortem. It's an emergency if someone gets woken up in a week once. Like, God, that's terrible. That's not okay. And I know of many other engineering teams who have started out with this philosophy of engineers own their code. You're responsible for it. It's humane, but this is your service. Like you should. Most engineers want this, right? They want the power to fix and understand their systems deeply. But if you start with that feedback loop and you manage it, it should never get that bad, ever. Ugh. How do we develop production excellence? This is the shittiest of all the slides. Well, invest in observability. I put some stuff, software engineers on call. So I like to think of it as almost observability-driven development. Like TDD is great, but it kind of stops at the edge of your laptop, right? As soon as you've got to hop the network, well, okay. And even if you have a copy of staging, that matches production, all this stuff, I hope you realize that it's not realistic. You don't have concurrency, you don't have, traffic, you don't have probably the same instance types, you don't have, and most of all, you do not have the original sources of chaos, your users. Even if, and this is kind of a specialty of mine, I have written this piece of software 3 times, capture replay, like capture 24 hours worth of traffic that goes into a system and replay it again and again on a copy. Done that 3 times. It is the gold standard, and sometimes it is worth doing for databases. Even then, you're not going to predict that Michael Jackson's going to die tomorrow, right? So you really have to be like, okay, here's what I can control, here's what I can't. And it's not cost effective to put too much. Again, you can see why I'm like, just think about what the serverless kids are doing. They have no fucks to give for staging. Sort of kidding. Okay. Now, apparently, according to my slides, we're going to jump around a little, and we're going to talk about observability and what kinds of things you need in your tools in order to get the kind of observability that lets you empower software engineers to be on call. Because how many of you have been on call before and like dealt with Grafana, Nagios, Graphite, hell on earth? Yeah. It doesn't speak your language, right? It's like, okay, you've got uptime and free memory and shit, and you're over here going, okay, but I just wrote this function, I'm talking to that service. They're disjoint, which is why I have put teams of software engineers on call 3 or 4 times. Sometimes succeeded, sometimes failed horribly, sometimes failed and then succeeded with the same team. And the difference was the observability tooling that they had. It was, did they have something that let them just go and slice and dice and find the source so they weren't frustrated, they were actually empowered, right? Or were they suddenly plopped in a land where they're like, I'm a stranger here. This does not speak to me at all. And suddenly they have 2 jobs, right? And that's not fair. It's not fair to anyone to give them 2 jobs. Observability is a newish term, and it's not super new. Like, people have been using it as a generic synonym for telemetry for a long time. More recently, we've been using it in a much more technical sense to refer to, well, we took the definition from control theory, right? How much can you understand about the inner workings of a system just by observing its outputs? And applied to software, this would mean, how much can you understand your system without SSHing in and running strace, right? Also, can you ask any question of your system without having to ship new code to ask that question, right? It's about gathering the level of detail that the primitives will let you answer the question to diagnose anything that comes up without having to go, well, we aggregated on this, and I actually care about that, so I'm gonna have to redeploy some code and hope it happens again. That's not really okay. First and foremost, this is an instrumentation game, 100,000%, right? Traditional monitoring is very much, you've got one piece of software checking up on another piece of software, just like, here's my threshold, you okay? Check, check, right? Which meant that we had to predict what thresholds we wanted to check, write a bunch of, I'm gonna check these things. And it's not a first-person narrative because, spoiler alert, as a software engineer, you do not actually give a shit about the infrastructure and its health. You don't care. You should not have to care. I don't want to have to care when AWS is having problems. I want to be completely abstracted away from that. I never am going to another colo again. What you do care about is the ability of every request to execute from end to end, right? Every time a user connects, traverses your code, you want to be able to see that it complete. So like, your systems can be 30% down, right? If one of your AZs is down. And you should never notice. Your users should never notice, right? You shouldn't have to care. From the perspective of your instrumentation in your code, everything's cool. There's a lot more I could say about instrumentation. What is my time check? Do I have 17 minutes? Okay, cool. I'm gonna try and save some time for questions too. Events are super important. So like we have these data types that we've inherited from our forefathers who were extremely constrained on hardware resources. Hardware was super expensive, right? So like they're like, well, Jesus, I cannot possibly store this entire log line. How much data can I throw away and still have anything that is meaningful at all? And thus the metric was born, right? It's like a single number, you append some tags so that you can group them. Well, that works very well for some things, like monitoring infrastructure resources over time. But it does not do jack shit for you because you can't have high cardinality dimensions in those tags. It's only good for low when I say cardinality, I know Liz is going to hate me. She's say that you have a collection of 100 million users, right? Any like unique ID is going to be the highest possible cardinality value that you can have. Slightly lower, but still quite high, would be like first name, last name. Very low would be gender, and lowest of all, presumably species, right? So when you think about metrics, they're all geared towards those low cardinality dimensions, which are fine for looking at servers in aggregate, but not useful if what you care about are things like these. Request IDs, shopping cart IDs, header types, literally everything you could ever want to use to debug, right? And logs are honestly not much better because logs, strings, they're messy, they're strings, they're outputted like willy-nilly throughout the request path. They can take your service down. They can DDoS like some remote service. They're sloppy. And most importantly, they've lost a lot of that connective tissue that you need to derive context, right? Context is everything when you're debugging. If you can say, here are 500 values that all describe this request. That is going to be very easy to find when you're debugging, when you're looking for needles in a haystack, right? If you have one value and a couple tags, that's not useful. If you have, a few dozen log lines and a request ID, but you have to do a bunch of post-processing to knit them back together into a single event, well, that's also very painful. So like the canonical, the way you want to store this data is an arbitrarily wide, structured event. Structured, I hope, goes without saying. Because that says all of these things are true at once. All of these things describe one event. And when you're doing microservices, you really want it to be one request, one event generated per request per service. When you're doing serverless, obviously it's more of a wrapper around your event, blah, 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 lambdas, I don't know, whatever you kids are doing these days. High cardinality is not nice to have, though. If you're debugging, it's everything. So, funny story, nobody seems to want to spend like 5 times as much on observability as they do on production. I personally think it would be money well spent. I have yet to convince anyone who holds any power of the purse over that. Fortunately, sampling is super powerful. If you do it in a dynamic way where, so all of the 200s that come into the root domain, are they all useful? No, they're not. They're boring. Throw a lot of them away, keep 1 out of 20. All of your 500s you actually probably do care about, right? Every request to the payment endpoint you actually do care about. But it turns out the vast majority of the traffic on your system you do not care about. You care about only in aggregate. And events work really nicely for that. They help you control costs and bandwidth. And you can I think of sample rates as the successor to tweaking your pager rules. It's kind of one of those things that's never completely done. You need to do once in a while, but it's not really that big of a deal. I really hate dashboards. You know how when you're debugging a problem, you're like, I've crafted this perfect dashboard. I am going to save it so that next time this happens, I can jump to it immediately. Okay, but by the time that happens again, you've generated another 500 dashboards thinking the same way. And they also have this way of locking you into, you think that what you see in front of your face is what actually exists. How many times, I do not know how many times I have been debugging something intently and 6 hours later realized it was something that had stopped sending a stream of events. I really just think that dashboards are great for passively paying attention to something, and they're a great jumping off point. But if you can't dive down into your dashboard, if you can't make it interactive, if you can't slice and dice, then they're encouraging you to be very lazy and not think about your infrastructure. And I really kind of think of them as every dashboard is an artifact of some past failure. It's just throw up a gravestone. The problem with them is that they make you jump straight to the answer without actually formulating the question, right? And when you're debugging, when you're understanding your software, forget debugging. This isn't just a thing that you do when things are down or broken. You should be in this constant conversation with production. You should be constantly checking muscle memory. Did what I just shipped, is it doing what I thought it would? Does anything else look weird, right? We all need to spend so much more time immersed in production. We need to build the tooling to make it safe for people to be in production, because all the time that you spend in any other environment is kind of a net negative. It's wasted. It's not only wasted, but it's teaching you the wrong intuitive assumptions. It's teaching you the wrong habits. It's teaching you that it's okay to type drop database into the REPL. It's teaching you terrible things. You should spend less time in every environment other than production. Everyone should be in production all the time. And it should not be a big deal. Let me rant about aggregation as well. Aggregation is terrible. Aggregation, when you're aggregating at right time, that's just a way of saying, I predict that I'm only ever going to want to answer these questions. In order to have observability as distinguished from monitoring, you really need you need to be able to work your way back to those raw events or a sample of the raw events so that you can ask new questions at read time. Because once the way that time series databases traditionally work is that you define an interval, and all the things that happen over the course of that interval get smushed into one value. So then when you compute your percentiles, what you're actually computing is an average of averages. Hope I don't have to point out the problems with this. You must be able to ask new questions. Because honestly, your users don't care about the system health. All they care about is their experience. Services need owners, not operators, because owners have context, and owners care, and owners suffer the consequences. Three very important things. Software engineers, I think, across the board tend to spend way too much time looking at their code in elaborately falsified environments, not nearly enough time in production, which, again, I love this about serverless. Now, what I don't love about serverless is that so many of you seem to be trying to run away from this as fast as you can. We can talk about that after class. Observability-driven development to me just means you take it a step farther. It means that you, and use feature flags. Yeah, I'm not saying be sloppy. I'm not saying don't be safe. Use feature flags. Use progressive deployment. Do it safely, but watch it run in production. And the way we use Honeycomb is typically we we use it to decide if a thing is even worth building, right? When we shipped compression recently, we're like, well, should we roll out compression? We don't know. Let's add a little bit of instrumentation and see, right? Let it run for a day, and we could see what the distribution of reclaimed space would be, who would be impacted, who would get, who would have worse performance, who would have better. We're like, yeah, this is totally worth doing. So we shipped it, right? And you ship it, and you just check. You're validating yourself. High cardinality dimensions like build ID. Very useful. You have to watch it run in production. If you're only looking at production when it's broken, you're not going to actually understand what normal looks like. I really believe that engineers should be interacting with production every day. Not just so many software engineers, when you try and put them on call, they have this internalized fear. They're just like, oh. And sometimes this has been drummed into them. It's not their fault. Like, they've been yelled at, which is not cool. Don't do that. And sometimes it's just that they only ever look at production when something is terribly wrong. So fix that. And tonight we test and prod. I know you saw my shirt. So for the future, this is what you need your tools to have. I'm really, really loving the direction that serverless is going in, and I love that I get to tell so many people, just think about what serverless is doing when you're instrumenting, when you're thinking about production. So please don't forget to wrap operability into the rest of your direction. And what you get in reward for all of this pain and suffering is drastically fewer paging alerts. You can delete all your pager rules except for the big three, like request rate, latency, errors, maybe saturation, probably not, and a couple of end-to-end requests that traverse your most important code paths that make you money. That's it. Delete the rest. People have been leaning on their hundreds and hundreds of paging alerts for to help them debug, which is insane and will kill you, I'm pretty sure. So don't do that. Delete them all. But you might need to use Honeycomb first. So, all right, that's all I've got. Thanks.
All right. So does anybody have any questions? We got about 6 minutes. Any questions for
Ask me
Charity?
anything.
AMA right now.
So that's loud. Yeah, at one end you have a system where everyone on every team can write a query, get a nice flame graph with like the eventing going through all the systems, and it comes back. It's beautiful. At the other end, you have to call 5 different teams and like piece together from each of their logs what the hell just happened, why things are broken. What's a good step for someone that's closer on the other side to start getting towards a more instrumented, more observable set of systems?
Okay, let me repeat. I think I understand what you're asking. You're saying when, everybody has access, but the sources of data are so fragmented and you don't have control over them, and there are a bunch of other teams that run them. Honestly, the only one that you need to start with is your application, which you presumably do, because it's nice to be able to witness both sides of the transaction, but you can tell where the time is going, if it's going to this cluster or that host or whatever, and that's usually enough for you to go on when it's when it comes to the next steps. Another thing I should have mentioned was tracing. Tracing is so absolutely necessary. It's not a cure-all, but it's super important because like some categories of problems you can only really see by that, when something goes from 8 milliseconds to 800 milliseconds. But some problems you can only see, like if 8 milliseconds goes to 12 milliseconds, but for 75% of your queries, that can be just as terrible. And so I think the ability to toggle back and forth between tracing and events is super key.
Another question?
This one's not a trap. So I work a lot in compliance, PCI DSS, a little bit of kind of HIPAA, kind of FERPA. Resources for me, because obviously serverless, you're required to have segregated environments. You're required to do specific deploys. Thoughts, comments?
For observability in particular?
Observability, or for even keeping your engineers in production. PCI, you absolutely have to have segregated
Totally.
environments.
So what we do for people who have these kind of data needs is we ship a proxy that you can stream events through on your side. So your events never leave your site. We only get the encrypted representation minus any keys or a mapping of the hash to the event. And we can never decrypt your data, so we can sign whatever they're called, those terrible lawyer agreements. I think that what you're asking them about, though, is more about the divide between operational data and like auditable data. And this is the kind of thing where I feel like everything that I say is going to be super obvious here. Liz, feel free to jump in if you have a better answer. But I feel like early on, it's good for teams to get used to the discipline of don't cross the streams. You want to be very profligate with your debugging data. You never want to incentivize engineers to not capture something that's useful, but you want to educate them and make sure that they know that these types of things you can't. And then like running some post hoc checkers on the streams of data to detect if something is leaked is usually valuable. Yes, ma'am.
Sorry. So, funny story. I used to work on Google's internal HR systems, so I'm very much familiar with the kind of segregation of duties stuff. So the ways that you can think about still being able to segregate your duties are thinking about, right, like what is your two-person factor, right? How do you avoid one person pushing out something and then having it misperform or do bad stuff, right? And that's not really tied to can you touch production or not, right? It's can you monitor what people are doing in production? And even, right, like with observability, like Charity was saying, can you separate the debugging data so that people can have access to the debugging data without necessarily being able to mutate production, right? If no one can SSH your systems, right, that's fine, right? Developers shouldn't have to SSH the systems, but they should still be able to view the instrumentation and get access to the observability in production. Does that make sense?